Welcome to This Explainer. Today, we're diving into the mathematical guardrails of human decision-making. We're going to unpack this really fascinating concept called the consistency ratio. It's basically a tool that forces us to confront the actual logic, or, let's be honest, the complete lack thereof behind our choices. So, here's our roadmap. First, we'll look at the human inconsistency problem. Then, we'll define the consistency ratio itself. After that, we'll peek inside the mathematical black box, benchmark our choices against the random index, and finally, see how modern software actually comes to the rescue.
All right, starting with Section 1, the human inconsistency problem, or really the fundamental flaw in human judgment.
Now, despite our absolute best intentions, human rationality is inherently bounded. Think about it and ask yourself, are your decisions actually logically consistent? When you're trying to evaluate multiple criteria, say you're weighing cost, quality, location, and speed all at the same time, it is just incredibly easy to lose your concentration and totally contradict yourself without even realizing it. Our brains just simply aren't wired to juggle that many variables perfectly all at once.
So the crucial point here is that perfect logic requires strict adherence to what mathematicians call the transitivity rule. It sounds fancy, but in its simplest form, this rule just states that if alternative A is preferred to B and B is preferred to C, well then logically, A absolutely must be preferred to C.
Let's actually ground this with a super concrete example. Imagine you're comparing fruit. Step 1, you decide an apple is preferred 2 times over an orange. Step 2, you decide that an orange is preferred 3 times over a banana. If we follow that transitivity rule, Step 3 mathematically dictates that your apple must be preferred exactly 6 times over the banana. Because 2 times 3 is 6. But if you deviate from this logical progression when you're mapping out your preferences, like say you only rate the apple 4 times better than the banana, well, you've just introduced a mathematical inconsistency right into your decision matrix.
But, reality doesn't exactly play by strict algebraic rules. As this quote perfectly points out, human nature is often inconsistent. For example, in football, it is entirely possible for the team at the absolute top of the table to lose against the team at the bottom. We are naturally contradictory creatures, right? Sometimes our preferences just loop right around on themselves.
Moving on to Section 2, defining the consistency ratio, which acts as our mathematical guardrail. Because we know humans are, wonderfully but fundamentally flawed, decision-making frameworks like the Analytic Hierarchy Process, or AHP, provide us with a mathematical safety net. And the absolute core of this safety net is the consistency ratio. Think of it like an objective alarm system built right into AHP. It detects and measures exactly how much your pairwise comparisons actually contradict each other.
In this alarm system, it has a very specific trigger point, 10%. This is Thomas Sati's golden rule. Sati, who actually pioneered this whole process, established that your matrix's inconsistency must remain under 10% to be considered acceptable and meaningful. If your contradictions push that number any higher, well, your data is just too flawed to trust, and you've got to go back and completely reassess your choices.
Okay, Section 3, let's look inside the black box, the math behind the magic.
So how is this 10% limit actually calculated behind the scenes? Well, take a look at this. It brilliantly illustrates what a real comparison matrix looks like in practice. Here, we're evaluating retail locations. We're comparing visibility, competition, frequency of foot traffic, and rental costs. And this gives us our very first crucial mathematical variable, n. Since we have 4 criteria we're looking at, our matrix size n simply equals 4.
With our n established, we start by calculating the consistency index, or CI for short. We do this by taking the maximum eigenvalue of your matrix. Yeah, that's that lambda max symbol you're seeing right there. Subtracting n, and then dividing the whole shebang by n minus 1. Now, don't worry, you absolutely do not need to be a linear algebra expert to grasp the main takeaway here. All you really need to know is that this CI formula is measuring the raw deviation of your personal judgments away from perfect mathematical consistency.
Next up is Section 4, the random index, or RI, which is all about benchmarking against randomness.
Now, just having a raw consistency index score doesn't actually mean a whole lot until we have a benchmark to compare it to. To get our final ratio, we contrast our CI with the random index, or RI. While the CI represents your own thoughtful judgments, the RI represents the average inconsistency of 500 completely random matrices. So, by dividing our CI by the RI, you are literally comparing your human logic directly against a baseline of pure, unadulterated random chance. To even make this calculation possible, researchers went ahead and established RI constants based on your matrix size. Looking at the numbers here, if you're only comparing 3 items, your RI baseline is 0.58, but jump to our retail location example where our N was 4, and the RI benchmark goes up to 0.90. These constants were derived by generating those 500 random matrices for each specific size, which basically gives decision makers this strict, pre-calculated baseline to validate their own matrix against.
Finally, Section 5, Software to the Rescue, because automating the complex math is a real game changer.
And you know what the absolute best part of all this is? You never actually have to do this complex eigenvalue math by hand. Modern tools, like Make It Rational or custom web calculators, feature these amazing intelligent consistency diagnostics that act as real-time guardrails. As you input your data, the software is just running in the background, calculating your maximum eigenvalue, your CI, and your CR live. If you tip over that 10% mark, boom, it throws an automated alert, pinpoints your exact contradictory judgment, and even suggests the exact mathematical target value you need to fix it. It literally holds your hand and guides you toward rational thought.
So as we wrap up this explainer, I really want to leave you with a final thought to chew on. Knowing your inherent human bias and knowing just how incredibly easy it is to contradict yourself without even noticing, do you still blindly trust your gut on the big choices, or do you let the math validate your logic? The next time you have to make a complex, high-stakes decision, ask yourself, would my reasoning actually survive the rigorous, unflinching test of the consistency ratio?